Welcome back to Planet Numeracy. Today we'll be talking about the elimination method. So pay attention, algebra folks. If we're just meeting, my name's Mark Noldy. I've been teaching high school math for over 20 years, and that includes my 4 daughters. So pay attention, we're getting ready. I'm going to show you 4 examples of the elimination method to solve systems of equations. So today I'm going to show you elimination method. Previously, I had shown how to do substitution method, but elimination method is called elimination method because it is used to eliminate a variable. So I'll show kind of an easy one here. Notice how I have a plus 2y and a minus 2y here. So if I were to add these two equations together, I get 6x equals 12 because these two eliminate. That's why it's called elimination method. And 12 divided by 6 is 2. Once you know what one of the variables is, you can go to either one of the previous equations, substitute 2 in this case for the x. So 2 plus 2y is equal to 8, or 2y equals 6, or y equals 3. So we have a solution, 2, 3. And remember, this is interpreted as the intersection between the graph of these two lines. Let's look at one more. So this is a second one. This one also lends itself to elimination, eliminating these two variables. But one thing I feel like I forgot to say on the first example is, why is it that we are allowed to add these two equations together? And the answer is, when I add two equivalent equations, remember, are two equations that have the same solution. They have the same x and the same y, because they're lines, and where they cross is the solution to this system of equations. So when I add two equivalent equations together, in this case, I create another equivalent equation that has the same solution as the previous two. Continuing, and we get that x equals 3. So notice that I did not label. I suppose I could have said 1 plus 2. But now I'm going to go back up here and, I don't know, pick any equation. Doesn't matter. So x plus y, that's 3 plus y equals 4. And when I subtract 3 on each side, I get y equals 1. So 3, 1 is the point where these two intersections, or where these two equations, these two linear equations intersect. Let's look at the next one. Notice that this equation doesn't have the same variables for x, the same coefficients for x, so I can't add to eliminate those or subtract to eliminate them. Here I cannot either, because this is a minus 4 and this is a plus 2. However, looking at this, looks like I could multiply this equation by 2. And if I did that, I'd have a plus 2 to eliminate with this minus 4. So let's see how that happens. So nothing happens to the first equation. Still 2x minus 4y equals negative 4. But when I multiply this equation by 2, multiply by 2 on both sides, we have a 3x over here. So 3x times 2, that gives us a 6x. Let's see, 2y times 2, that gives me a 4y. And this is what we wanted to have happen. We wanted this negative 4, whoops, lost my pointer, this negative 4 and this plus 4 to be the opposite so I can add them together and eliminate the y's. So last one, multiply 18 by 2. 18 by 2 is 36. So now, let's just switch colors to be interesting. Going to add together. Notice these two add off. So I've eliminated the y. So now I'm just dealing with x. So I have 8x equals 32 because negative 4, 36 is 32. Divide both sides by 8. So x is equal to 4. Now that I know what x is equal to, I could go back to any equation that I want to. I could go back to this equation, this equation, this equation, this equation, substitute 4 in place of the x in any of them, and I will get the same y answer. So, let's just be different. Start over here with equation 2, and I'll say 3 times x, which is 4, plus 2y equals 18. So I started with this original equation, and I'm going to, let's see, we'll step it out all the way. 3 times 4 is 12. This is still equal to 18. So when you subtract 12 on both sides, you get 2y equals 6, and y equals 3. So I have x equals 4, y equals 3. So the point where these two lines would intersect is the point, oops, I did it backwards, is the point, try that one more time, is the point 4, comma, 3. All right, I think you're getting the hang of this, but I will still show one more example for good measure. All right, last example. Sometimes you will need to eliminate a variable, but you have to multiply both equations by something. So notice I can't multiply the 2x by something to turn it into a 5. And I can't multiply the 2y by something to turn it into a 3. So I have to multiply both of these equations by something to get equivalent equations that I can eliminate. So general rule of thumb, students always ask me, how do you know that, do I make this into a 10x by multiplying this by 2 and this by 5? Or do I multiply this by 3 and this by 2? General rule of thumb is 6 is a smaller number than 2, so they have a lower multiple, so least common multiple. So that's what I would multiply by. So let's turn this first one into a 6y by multiplying by 3. So that would yield, let's see, 5 times 3 is 15x, getting the hang of this, right? And 2y times 2y, lost my pointer, times 3 would give us the 6y. This was our goal, to make this into a 6y. And last but not least, negative 3 times 3 is negative 9. Now, equation number 2. I wanted to make this into a 6y. So making a 6y by multiplying by, let's see, 2. So multiply that guy by 2. So the whole equation becomes 4x plus 6y equals, let's see, negative 10 times 2 is negative 20. So notice in this instance, these 6's are not opposite. So I'm not going to add these two equations together. Rather, I'm going to subtract them. So I'm going to subtract this equation from the equation above it. And I'm going to then figure out what the x is. So 15x minus 4x is, let's see, is that an 11x? And this becomes a 0y. Don't really have to write that, but just to emphasize. And subtracting negative 9 minus negative 20 is positive 11. So we have x equals 1. So now that you know what x equals, it doesn't matter which of these equations you go back to. Maybe I'll go back to this one because it looks like it has kind of small numbers to work with. So I'm going to go back to equation 2, original equation 2. So that gives me, let's see, 2 times x. Let me color code this a little bit easier for you. And in place of the x is where I'm putting the 1 from over here. So continuing, we have multiply together, get 2 plus 3y equals negative 10. 3y equals negative 12. Remember, don't get your negatives mixed up here, but negative 10 minus 2 is negative 12. And finally, y is equal to negative 4. Negative 12 divided by 3 is negative 4. So my solution is x is 1, y is negative 4. And that is 4 solid examples on how to use elimination method.
Thanks for watching to the end. Remember that math is not a spectator sport. I tell my students that all the time. You have to pay attention, you have to do the work, and you have to not give up. Do those 3 things, and you'll be doing fine in your math classes. Down in the comments below, let me know if there's any other topics that you're struggling with, and I would definitely be willing to make some videos on those as well. And if you got value from this video, please give it a like or a thumbs up, and join the Numeracy Nation by subscribing.